Good afternoon, grade 8s, and welcome back to another exciting episode with Masculine Learning and maskitv. Today's focus point will be on drawing graphs. Now, this word graphs should ring a bell because last week we focused on the interpretation of graphs. And I want you to note the difference. Last week we were given graphs through information. Now, this week, they're going to give us information, and our responsibility would then just be to draw the graph, all right? So it's just the opposite of one another. Now, obviously, before we start any lesson, we need to look at what we wish to achieve at the end of the lesson. So our objectives are as follows. We need to identify and label axes correctly, and an axis consists of an x-axis and a y-axis with appropriate scales. We need to plot ordered pairs, and an ordered pair is an x value and a y value accurately on a Cartesian plane. And then lastly, we need to draw graphs from a given table or values, or we're going to use an equation. Just to pay attention, we're going to draw straight line graphs from a table of values or from an equation. All right. So again, last week we spoke about graphs and how important it is to understand the concept of graphs. But again, graphs are powerful tools that help us understand patterns, it helps us see trends, and it also shows us the relationship between data or the relationship between variables, all right? It allows us to represent information on a set of axes, which I explained just before this, all right? We use the Cartesian plane, so a big part of today's lesson will be focused on the Cartesian plane, and we just said before this now in the objectives, we're going to focus on what we call the x-axis and the y-axis. Right, and from there we're going to draw lines or curves. And just the recap of last week, by learning how to draw graphs, we can better understand equations, we can solve problems, and we can connect mathematics to the real world out there, okay? Now, before we can understand the concept of drawing graphs, grade 8, we need to understand what we call the Cartesian plane, all right? And here we have an example of a Cartesian plane. It is basically two lines intersecting. We call the one line the x-axis, and we call the other line the y-axis, right? It is represented by a horizontal and a vertical axis from a coordinate system. So very, very simple, or very, very briefly, I'm going to explain to you how easy it is to understand this. So this point over here is what we call the origin. So at this point, the x value and the y value is equal to 0. So from this point, any number to the right of my origin, meaning all the x values on the right, is always positive. And all the x values going to the left is always negative. All y values going up is always positive, and all y values going down is what? Negative, right? So if we look at this holistically, it is able for us to derive points. So if we look at this point over here, A, what do we notice about A? If we go down to our x-axis, it is given a number, and the number there is 3. So it means that my x value at this point A is 3. And if I go across to my y-axis, I see a number there. What is that number? The number is what? 2. So therefore, I have what we call an ordered pair, which we explained is an x value and a y value, right, which we get directly from our Cartesian plane. So if I were to just randomly put an R here, and I were to tell you what are the coordinates of R, what x and y value exists at R, it's very, very simple. So on this dot over here on this point, I go down to my x-axis, and I will notice the value there is what? -8. And then I go across to my y-axis, and I notice there that the y value is 3, positive 3. So remember, right and up is positive, and left and down is what? Negative. What's more important to understand is that this here, it never stops. It doesn't stop at 9. This axis actually continues forever. It continues to infinity, okay? That was just a brief explanation of what the coordinate plane is all about. Very important to understand before we can actually sketch graphs, okay? I'm not going to read everything because everything will be explained as we go along, but basically I explained that any position in the plane is represented by an ordered pair, which is an x and a y value. All right. We explained that the horizontal axis is all my x values, and we explained that the vertical axis are all my y values. All right. The vertical axis is called the y-axis. The horizontal axis over here is called the x-axis. Right. The point where the axes intersect, which I just explained before this, we call the origin. Its coordinates are what? 0 and 0. Where do they intersect? What's another word for intersect? Yes, it is cut. So they're cutting at this point, and at this point the x value and the y value is equal to what? 0. And then lastly, we also refer to the x and y axis in the Cartesian plane as a system of axes, right? So the x-axis and the y-axis is what we call a system of axes, all right? Okay, so now we go into the main part of today's lesson, and that is drawing graphs. And there are steps that we have in place before we can draw the graphs. What is it telling us here? It is telling us to use your standard or your given equation. So it will give you an equation, right? And then what do? We substitute the x value into the equation, and this will then give you a corresponding y value. Now remember, boys and girls, last week we spoke about the dependent and the independent variable, if you can remember. And we said that the dependent variable, right, is my vertical axis, and that is dependent on what the input is, right? We call it the axis that is being observed, right? Then we spoke about the independent variable, and for the independent variable, that is usually the axis that is manipulated. So here we have control over what we do, but the output value is dependent on what we do with our input values. So it is all the same thing. They're just adding some new terminology in there. They're calling it now the x-axis and the y-axis, or they're using the word equation or the x value and the y value. But it really comes from understanding the importance of last week's lesson, right? How the relationship between the dependent and the independent variables, okay? So we can also do it the other way around. We can substitute a y value, right, and we can get an x value. So we can be given a y value, we can substitute the y value into the equation to give us a corresponding x value, all right? This pair is called a point, so we've dealt with points here. And then we refer, once these points are plotted, so once we have plotted all the points, once we have substituted our input values, right, and we've gotten all our output values, we can take these points and we can then draw, or we can join the points. And these points will then tell us whether the graph is a linear graph, which is made up of a line, or a non-linear graph, which is not a straight line. Again, concepts we have gone over last week. All right, so here we have an example. So it says here, complete this table by filling in the x and y values for the equation y is equal to 2x plus 1, okay? So, So, look at this step over here. They told us that we're going to use a standard or a given equation. Where's our equation? Here is our equation given. So this here will essentially lead us to our answer, but we need to be careful in terms of what we need to do, especially our substitution, all right? Now, if we just go back, look what it says. It says substitute the x values or the y values into the equation. So if I substitute an x value, I will get the corresponding y value. If I substitute a y value, I will get an x value, all right? So I'm gonna do exactly that. Don't look at the answer for now. I want you to understand and take note of what I am doing. All right, so look what I need to do. Remember, for every x value, there's a corresponding y value, and these two values will form a point. And we're going to plot these points on the Cartesian plane to see whether we have a linear graph or not, okay? So there will be some calculations first, and after the calculations, we will then draw the graph. So let's first complete the table. So here's my equation. So my equation is given by y is equal to 2x plus 1. What is my first x value? My first x value is -2, so I'm going to substitute. Keyword, substitute. Substitute means in place of. So in place of x, I will put what? -1, right? So we can say, so for x equal to negative 2. Oh, they did the first one fast already, but let's check how they got to negative 3, right? So when x is negative 2, look, I'm going to say y, which I'm now looking for, is equal to 2. Remember, we're now substituting negative 2 in place of x. So I have negative 2 plus 1. So now I say y is equal to, what is 2 times negative 2? It is negative 4 plus 1. And y is therefore equal to negative 3. This is from integers, okay, from integers. And we can see here, my x value is negative 2, and my y value is what? Negative 3. All right, let's go to the next one. Now we're doing for x equal 1. So for x equals negative 1, we're going to say y is equal to 2, open bracket. In place of x, I will now put negative 1. So I have negative 1. I'm using my standard equation here, plus 1. So y will be equal to negative 2 plus 1. And what is negative 2 plus 1? It is just negative 1. All right? So when my x value is negative 1, my y value will also be negative 1. So I have negative 1 there. All right? Now I'm going to do for x equal to 0. So wherever I see x, I will now put 0. So I'll say y is equal to 2 times 0 plus 1. So y will be equal to 2 times 0 is what? Sorry, that was a mistake over there. Let me just make that neater. Let me erase that. There we go. So 2 times 0 is 0 plus 1, and 0 plus 1 is just what? 1. So for my x value, 0, y is what? 1. In fact, let me do that here. So when x is negative 1, y is negative 1. When x is 0, and then y will be what? 1. All right? Let's just move that a bit up, and let's find the other corresponding values. Okay? So our next x value that's given to me is 1. So now I will say for x equal to 1, I will say y is equal to 2 times 1 plus 1. So now y will be equal to 2 multiplied by 1 is 2. And I'm going to add the 1 to the 2, which will give me what? 3. So it means for my input value of 1, my output value is what? 3. So here I have 3. Now grade 8, you need to be careful here. Look what's given to me. Is this an x or a y value given? A y value is given. So I cannot substitute 5 in place of x. I must now substitute 5 in place of y. And if I substitute 5 in place of y, that will ultimately give me an x value. Okay? So we can see here all of it is corresponding. So let me write down my equation. So my equation is given by y is equal to 2x plus 1. Remember, I'm given my y value over here now. So I'm not going to substitute x as 5. So I will say for y equal to 5. So look here. So here's y. So in place of y, I'm going to substitute 5. Right? So 5 will be equal to 2x plus 1. Isn't it? So can I see now, if I look at this equation, I can see that my unknown, or the variable I'm looking to solve, is no longer y. It is now x. So the first thing I will do is, I want to get this 2x on its own, so I will subtract 1 from both sides. So if I subtract 1 from the right-hand side, I will just have 2x. If I subtract 1 from 5, I will have 4 over here. And obviously, if I want to get x on its own, I will need to divide both sides by 2, right? So 2 divided by 2 is 1, and 1 multiplied by x is just x, and 4 divided by 2 is 2. And that, boys and girls, is how I got to my answer for 2 over there. So the next question says, draw a graph by plotting the ordered pairs on the Cartesian plane. So this is just the first step to our answer. We need to do, or we need to complete this table correctly, okay, before we are able to plot our points. If we just substitute one thing wrong, it's going to affect our entire answer. I'm going to put a 2 in there so we know how we got our 2. All right, so I'm going to do the following, right? I'm going to go to the next slide, and I'm going to show you, exactly what they have done. Right? So I'm going to draw it here so we can see both. So my first point is negative 2 and 3. Can you see here? Where x is negative 2, y is negative 3. And then I have negative 1 and negative 1. And then I have 0 and 1. and then I have 1 and 3, and then I have 2 and 5. And our responsibility now is to plot these points on the Cartesian plane, right? And then eventually draw the graph. So let's go to the next slide and see. There we go. So look at the first point, boys and girls, -2 and 3. So I go to my graph, and where x is -2, which is here exactly at this point over here. So x is -2 there. So look here, these are all in units of 1. So it's 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, etc. So I keep my finger. So an easy way to do this is I keep my finger on -2, which is the x value, and I go down or up to where y is what? 3. All right? I think it is -3. Yes, it is -3. I forgot the negative there. All right? So there we go. So where x is 2, I go down to where y is -3, and I make my first dot over there. Can you see? There's my first point. There's my first ordered pair. Done. So I can take my pencil and I put a tick there. Done with that one. Next one, where x is -1, y is -1. So where x is -1, remember, this is my origin here, 0 and 0. So 1 unit to the left would be -1, and I go 1 unit down, which is also -1. So this is where x is -1 and where y is -1. There's my next point. All right? So I'm done with that one. Let's go to the next one. Where x is 0, x is obviously 0 here at the origin. So where x is 0, y is 1. So I go 1 unit up to where y is 1. So I put a dot over there. Remember, at this point, I'm not here drawing my graph. I'm just plotting my points. So I'm done with that one. Now I go to the next one, right? Where x is 1 and when y is 3. So x is 1 at this point over here. I go 3 units up to where y is 3. I draw my circle over there to indicate my next point that I've plotted. So that one is done. And then lastly, where x is 2, y is 5. So where x is 2, y is 5, right? So x is 2 over here, and I count 5 units up, and I make a dot over there. And that, girls and boys, gives me 1, 2, 3, 4, 5 points. And then I just take my ruler, and I can see it is a linear graph. I can see it's forming a line once I connect these dots over here. All right, so it says there, you can plot these ordered pairs on the Cartesian plane using a point or a table. So we've used a table to substitute the x values into the equation to give us the corresponding y values. Okay, so we don't have much time left. That is how we draw points. But I want you, before we head into a break, I want you, girls and boys, to look at this equation over here. We have x squared plus 2, right? The one before this, it is very, very similar to what we had before this. So before we head into the break, I want you to look at this, quickly substitute these x values into the equation, get the corresponding y values. We're going to plot the points, and we're going to see whether this will give you a linear graph or a non-linear graph. Stay tuned. We had some time to look at the equation that's given to us, and then also what input values were given and how we will get our corresponding output values. Okay, so it is telling us here to use the equation y is equal to x squared plus 2. Okay, so here's our equation. Our equation is given by y is equal to x squared plus 2. To answer the questions that follow. So we need to complete the table. So again, we are given x values, or we're given input values, and our responsibility is to substitute these input values into the equation to see what our corresponding output values will be. Okay, so how many input values are there? There are 1, 2, 3, 4, 5, 6, 7. Right, so we're going to have 7 different calculations. Do not do this in your head, boys and girls. Show the calculation. In most cases, these calculations, it counts for marks. So although some of you can just look at the equation and look at the input value, and you, by inspection, can see what the answer is. Write it down. Beautiful exercise out of Classroom Maths on page 306, exercise 24.2. Right, so let's get into it. So what is my first input value? My first input value is -4. And I say there x equals -4. So I know I can't go wrong. Right? Now be very careful here. So here we have y is equal to. Now in place of x, I'm going to substitute -4. Now I'm working with a negative, guys, and we must always respect the negative. So if we substitute, especially if we're dealing with squares or with cubes, we always need to put it in brackets. Okay, we need to put it in brackets, whatever we are substituting. So what is our first x value? It is -4. So we have -4 squared, all right, plus 2. Can you see there? In place of x, I put what? -4. Now, it's very important for us to understand what's happening here. What does this -4 square mean? It is not -4 times 2. No, we must now exponents. We are multiplying the number -4 twice, right? So this essentially is -4 times -4. And what do we know? What are two negatives? Two negatives is what? A positive. And then 4 times 4 is what? 16. Right? I see many students make this mistake. They think that the square means times by 2. No, we are just multiplying whatever number the base is by itself, twice or thrice, whatever this number is given over here. Right? So we have y to be 16 plus 2, and 16 plus 2 is what? 18. Okay? So my first output value for the input value of -4 is 18. All right? Now, next one, where x is -2. So where x is -2. Right? So where x is -2, all right, I'm going to substitute. So I'm going to say that y is equal to, so in place of x, what do I now have? I have -2. I'm dealing with a negative. I'm dealing with a square. To avoid silly errors, I'm going to put it in brackets. There we go. So -2 squared plus 2. Okay, -2 squared plus 2. So what is -2 squared? -2 squared means -2 times -2. And -2 times -2 is +4. So here I have 4 plus 2. And 4 plus 2 is what? It is 8. So for my input value of -2, my output value is what? 8. Okay. Let me just make that 8 neater over there. Right, so I hope you guys are screaming, Teacher Abdul, 4 plus 2 is not 8, but it is rather 6. Okay, so here I need to have 6. There we go. Let's move on. So my next x value is -1. So remember, I'm using my equation. This equation is everything I need, right, to complete this table. So I have y is equal to, so x is -1, so I have -1 squared plus 2. -1 squared is not 2. It means, I'm going to do this. Let me use a different color quickly. It means -1 times -1. So a negative and a negative is a positive. 1 times 1 is just 1. So my answer there remains 1. So y is equal to 1 plus 2, and 1 plus 2 is 3 rather. 1 plus 2 is 3. All right. Let's put 3 there. So when x is -1, y is 3. Okay. So what's my next x value? My next x value is what? 0. So if I say x, I'll put 0. I think we're getting a bit comfortable with this now. All right, so we can go a bit faster. Okay. So y is equal to 0 squared plus 2. We know 0 squared, it is just 0. And 0 plus 2 is just 2. So I have 2 over there. Right. My next input value is 1. So I'm going to say when x is 1, so now y will be equal to 1. I don't need brackets now really, because I'm dealing with positive numbers, but it's still a very good practice to use brackets, right? So I'm actually going to keep my brackets there for consistency. So 1 squared plus 2. So 1 squared means 1 times 1. So 1 plus 2 is 3. So my input value of 1, my output value is 3, right? So where x is equal to 2, I'm going to say y is equal to 2 squared plus 2. So y will be, what is 2 squared? 2 times 2, it is 4, right? And 4 plus 2 is 6. So here I have 6 again. And then lastly, where x is equal to 4, right? So I have y is equal to 4 squared plus 2. 4 squared is 4 times 4. 4 times 4 is 16. So here I have 16 plus 2. Let me make that 6 a bit neater there. And 16 plus 2 is what? 18. All right? There I've did most of the calculations now. This is everything I need to draw my graph, right? So all I need now is just a nice set of axes, right? To complete this, okay? Now, let me just do this. Right. Why I'm doing this is because, what do I notice? I notice that my y scale is 18, right? So my biggest number is actually going to be 18, all right? So I'm going to count if I have 18 blocks here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Wow, I have 18 on the dot, right? So I'm going to do this. So I'm going to draw a line all the way down there, right? Here we go. There's a nice straight line. Let me just try and move this a bit more central. And I'm going to draw a line. And I'm going to draw a line across here. Okay, there we go. So this is my origin here, which is the point 0 and 0, right? And here I have 1, there I have 2. I'm not going to show all three. So the, sorry. Here I have 1, 2, 3, 4, 5, 6, 7. Okay, here I have 1, 2. In fact, I'm going to do this a bit different, all right? Because I'm limited with space over here, I'm going to make this in intervals of 2. So I'm going to go 2, right? I'm going to make 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, here I'm going to go still -1, -2, -3, -4, -5, -6. Okay, I'm going to plot the first 3 points, and then you see if you are able to plot the others on your own. Okay, so remember, I need a line going down here. So let me just do this. I need a line going down there to show my axis, and I need a line going down there to show my axis. There we go. Right? And very important, right? Remember here, I need to label my x, and here I need to label my y. So let us plot the first point, or the first 3 points. So where's x? -4. X is -4 over here. So I keep my finger there, and I go up to where y is 18. It is all the way up over there. So I make my first point there. Can you see? There's my first point. So I'm done with this one. Now I go to the next one, where x is -2. So x is -2 over here. Then I go up to where y is 6. So where's y 6? Y is 6 over there, right? Then I go to where x is -1, which is here. And where x is -1, y is 3. So I go up to 3, which is somewhere along there. I'm just going to take my last 2. So where x is 2, look here, x is 2 over here. What is y at that point? Y is 6 at that point. So I go up to 6. All right. What is x here? X is 4. So 3, 4 is here. And what is y at that point? Y is 18 at that point. It is here. Now, boys and girls, remember, I just did a few. I want you to do the rest on your own. But I'm just going to pose a question, right? And the question is, I'm asking you, is this graph linear or non-linear? Now, if we look, we have a point there, we have a point there, we have a point there. perhaps it can still be linear. But if there's a point there, and if there's a point there, do you think if we connect these dots, it will give us a linear graph? Personally, I don't think so, but I will let you get the opportunity to see it on your own once you have plotted all these points on your Cartesian plane and then sketch the graph in the end. Right, to wrap up, if it's saying here, determine the value of x if y is 11. What do we need to do there? Yes, we just need to substitute the number 11 in place of y over here and then solve for x. And I think we can end off with that. So our equation is given to be y is equal to x squared plus 2. It is telling me here that my y value is 11. So in place of y, I put what? 11. And what do I have to do now? Now I need to solve for x. How do I get x on its own here? I will subtract 2 from both sides. If I subtract 2 over here, I will be left with x squared. If I subtract 2 from 11, I'll be left with 9. And how do I eliminate a square? I square root. So I square root the right-hand side, I square root the left-hand side, and I can see that if my y value is 11, at that point, the x value is 3. And that, girls and boys, brings us to an end of the lesson on drawing graphs. I hope that you enjoyed it. I hope you could make the connection between interpreting graphs and drawing graphs. Interpretation, they're giving us a graph that is complete. We're reading information from the graph to answer questions. For drawing graphs, we are given an equation, and we are then using the equation to plot points, and we're using these points to put in the Cartesian plane to draw the graph. All right? If you need any help, don't forget to WhatsApp the number for Maski. They are always there at your service, 072 091 0388. If you have any questions, please ask. Most importantly, don't forget to like and subscribe, and I'll see you soon. Goodbye.
And now we enter our next exciting chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.